What would happen if the Earth was next to the largest star ever? There's actually two answers to that question. A, what would it look like? And B, what would actually happen to the planet itself? But you'll see, I have the Earth right here. There's no huge star in sight. Not even close, actually. In fact, the largest star actually goes by a name of Stevenson 218. Let's take a little scenic trip over there. Aha, we're here. I hope you like that trip. And you'll see it's actually very big, and it doesn't look like what you'd expect a star to look like. And why is it all deformed like that? Well, it's because it's such a big star. This star is so big, and the weight compared to it and its density just doesn't have enough to actually compress it into a ball, so it has this really awkward deformed shape. But how big do you think this star is? It's 2,000 times the radius of the sun, and it's actually 20 times the distance from the sun to the Earth, meaning you could fly to the sun and then fly back 10 times. And that's how big this star is. Enough gish galloping though. We want to see the Earth next to it. To do this, I had to do a little magic. I had to export the script and then go paste it over where Stevenson 218 is. And here it is. This is the Earth next to Stevenson 218. What? You tell me you don't see it? It's right in the middle of your screen, between these four arrows. Wasn't it obvious? In fact, just being this close makes this planet about 8,000 degrees Fahrenheit, which is, I don't know what it is in Celsius, but definitely a lot. And next to the Earth, this star looks really, really scary. Wow. I can't even comprehend that size. In fact, this star is so large, I can go where it should be night somewhere, and I can see the star looming over the sky. That's how big it is. And this right here is the wiki for the star. It has all the information we need. Its mass is 16 times more than the sun, and it takes 18 years to do a full spin, like one day on Earth. But here is the interesting part. You see the polar diameter? How it says 18.7 AU, and then equatorial diameter is 20 AU. Do you remember the distance between the Earth and the sun? That's how much bigger it is at the equator than it is at any of the polars. In fact, this mountain that you see on the screen right now is the distance between the sun and the Earth. That is how huge this star is. And here I am on the Earth during daytime. This is all the sky is this huge star, but this is actually toned down so we can see it. This is what it would look like from the Earth. You couldn't see anything. It's so bright. In fact, I also put the sun in here. This right here, this big dot is the sun, and this is what it looks like next to Stevenson 218. Oh my god, this star is so big, I can't even comprehend it. But before we check out what it would do to the Earth, I want to see what it would look like in the solar system. And here it is. This is what it would look like inside the solar system. You'll notice the solar system looks a little small because that's just how big it is. This right here is Uranus. That means Saturn, Jupiter, Mars, Earth, Venus, and Mercury are all consumed by Stevenson 218. We can even check out what it would look like from one of Uranus's moons. Looks something like this. It's actually pretty cool because we can see both Uranus and Stevenson at the same time. Other than the part that we're burning, it's pretty cool. But here in Universe Sandbox, we can see what would happen to the solar system and the Earth if we put it in here. So this game has a nifty replace button. We can do this and we can search up Stevenson 2. It's right there. It's already had for us. And replace. Here it is. This again is Uranus right here. This is the entire solar system. It's really big actually. And if we let this run, we will see everything immediately gets torched. This is, I believe, 1 month per second time step. So every second you see is 1 month of time. And then isn't it just beautiful? It all gets sucked into the huge star. And then I've also gave the Earth an orbit around the star so we can see what it does to the Earth specifically. Let me tell you, nothing good. It's been about 1 day and Africa is pretty much melted. You'll see it's starting to blow the planet away a little and the oceans are kind of melting. Now they're completely melted. We're at 15 minutes per second, so every second you see is 15 minutes. I think it's just kind of cool to watch. It's a little satisfying to see the Earth get destroyed like that. And you'll see it actually heats up the planet too, like the orange there, that's how hot it is. The Earth is nice and cold, 3,371 degrees Celsius or 6,100 Fahrenheit. And if we let this run and continue to simulate, eventually it's gonna blow the planet away because all the heat is just gonna scorch the planet. It actually, for a second, it looks like you could live up here because it's not as hot, but I'm not too sure.